Hello, I am Miss Peters, and if you were in the first middle school chemistry session, welcome back. And if you're new to these sessions, then hey, I'm so glad you're here. So, in the first session, we were talking about what chemistry is, and we've learned it is the study of matter and how it behaves. And we're going to be continuing on with delving into chemistry. So, speaking of matter, let's get down to the smallest parts of matter. We're going to be talking about atoms and the periodic table during this session. So, an atom is the smallest whole unit that matter can get down to, and it still be considered truly a piece of matter. They're very, very small, but the weird thing is they're made of even smaller parts, and those are called subatomic particles. So, we're going to be talking a lot about those. So, if you look at this picture here, you've probably seen this kind of picture before. It's pretty famous. This is a typical picture of what you would see is an atom. Now, this is a model of an atom, and models are great. They have a lot of advantages because we can't always study things we want to learn more about. The reason we can't study atoms directly is because they're so tiny. We can't see them even with most of our microscopes. And even with the few microscopes we can see them with, it's very, very blurry. We don't get a clear picture. So we use atom or models to be able to learn more about those that we can't see. Now, models also come in handy for things that are super, super large, like a planet or a star. So models will be something we're going to be using a lot in this session. So this would be a 2D model. And then I'm going to show you an example of more of a 3D model. Okay, so this would be a 3D model. So you can see that it's not just flat on a piece of paper. So I'll be referring to this along with the slides we'll be looking at. Okay, so I told you that an atom has 3 subatomic particles. And those 3 particles you can see listed there are called protons, neutrons, and electrons. So let me show you on the 3D model what those parts are. So protons and neutrons are always going to be these particles that are inside, okay? They're inside the atom, okay? And what's an area called the nucleus we'll be talking about. And then electrons, the third type of subatomic particle, are on the outside of the nucleus, okay? Now, if I zoom in on this model here, you can see the same kind of thing. So you can see how they both are the model of an atom. Just one is flat and labeled, and one is 3D and not labeled so much. So let's go ahead and look at more closely to the subatomic particles. So what I want you to take away from this session this time about atoms and their subatomic particles is that they have an electrical charge assigned to them. And electrical charges are really important for how these atoms or this matter behaves. And we're going to be investigating some of that. So protons have what's called a positive electrical charge. So if you notice there, you'll see there's a plus sign next to positive, and that's the symbol to show positive or an addition sign. Then neutrons, the second subatomic particle, those do not have an electrical charge. So we would call them neutral, meaning they're not positive or negative. They don't have a charge, no charge. And then finally, electrons are negatively charged. And you will see that symbolized with a negative sign or a minus sign. So if we zoom in on this model here, you can see once again, we had a round shape that makes up the totality of an atom. But inside of it, you have a nucleus, which is made up of those protons and neutrons. And they've got that kind of coming out so you can see it more clearly. Notice on the top right where the nucleus is with protons and neutrons, the greenish spheres are the protons and they have a plus on them. And that's because you now know they're positively charged. The neutrons don't have anything on them. Sometimes they might have a 0, but they can go with nothing also to show they have no charge. And then electrons are outside of the nucleus, and you can see that in that main circular area with the little E minuses. And again, now you know that the minus sign is for negative. So there's another model we got to look at there. So speaking of these charges, you've probably heard the phrase before, opposites attract. Okay, well, if you have, that's going to come in handy for you because it's going to help you remember something about these electrical charges and how matter behaves. So if we have positive charges and we have negative charges, that's going to affect things going on in that piece of matter. So let's look more closely here. So what's going to happen is like that phrase I mentioned, maybe you've heard of before, opposites attract. If you look at that top line, we have the word attraction, and then it gives us a symbol for an electron with the negative sign going towards another sphere, another particle that has the plus sign, meaning a proton. So that's showing us they are attracted to each other. Okay, they want to go towards each other. Now, the opposite of that is that if you have charges that are alike, they're the same, like two positives on that next line, they're not attracted to each other. It's the opposite. They're repulsed. So that is why it has the arrows moving away from each other. So they don't want to get near each other. They repulse each other and they move away. And then the same thing would happen for electrons being negative. If they're both in negative, they're not going to attract. They're going to do the opposite. They're going to be repulsed. Okay, so we'll be coming back more to why that matters when we do our investigations. So we've talked about the 3 subatomic particles that are inside of an atom. Now let's talk about the 2 main parts of an atom. And in those parts, you have those little subatomic particles. Okay, so the 2 main parts of an atom, the first one is the nucleus. We're going to start in the center of the atom and work our way out. So you can see on that picture there that we've got that center of blue and red spheres. That's your nucleus in the very center. In the 3D model, okay, my white and my gold spheres that are in the center, this is my nucleus, okay? It's made up of protons and neutrons, okay? And it's always the center of the atom. So that's one main part of the atom, and it holds 2 subatomic particles. The other part of the atom is called the electron cloud, okay? So the electron cloud kind of gives you a hint by the name, has the electrons in it. So the electron cloud model is actually the most up-to-date way we view an atom because we're still learning about them all the time. And inside the electron cloud, we have different areas that you would call energy levels. Sometimes we call them shells or orbitals because the electrons are in those energy levels and they're moving around all the time. So if we look around, look at this 3D model, the red spheres are representing our electrons. Now, remember when I talked about at the beginning that models have limitations and advantages. So the advantage of this model is we can see it in 3D, which is hard to do when you're looking at just a piece of paper or a screen, okay? The limitation, one of them to this model, is that the electrons look almost the same size as the protons and neutrons. That's not actually accurate, but it's okay because we're aware that there are limitations. We are aware this is not actually an atom because, like we already talked about, atoms are super, super tiny. But again, one of the advantages are this is all the electron cloud. Everything that's not the nucleus is the electron cloud. And these wire spheres that the electrons are on would represent those different levels that are inside of the electron cloud or different orbitals. So let's take a look at this picture here. Look at a 3D version. Oh, I'm sorry, a 2D version. So notice we have 3 different atoms listed there. The first one on the top only has one big circle around the nucleus. And that's representing the fact that that electron cloud for that specific atom only has one energy level in it. Okay. Then our second picture there going downwards has 2 circles that are representing the electron cloud. So that's telling us that, okay, this electron cloud for this atom has 2 energy levels in it. And then the third one there, of course, you figured out the pattern probably by now, it has 3 energy levels. Now, atoms can get way more than even these 3, but this is just to start giving you an idea of how the patterns work when it comes to atoms and their electron clouds and the energy levels inside of them. So something else that's cool about atoms, okay? So an atom is the smallest piece of matter, and all matter is made up of elements. And I'm sure you've heard about the elements before. Well, each element that exists in our universe has its own specific, unique atom. Just like how you are you're completely unique to anyone else, unless you happen to be an identical twin. But that's for another time probably in biology, you have your own unique set of DNA, okay? Completely unique, and it makes you the unique person you are. Well, atoms also have their own unique characteristic, okay? So if you look here, we have hydrogen, carbon, nitrogen, oxygen. We now know, looking at them, we've gotten familiar. We know that those are all different kinds of atoms, even though they look a little bit different. So you're going to find out next what it is exactly that makes them the unique atom that they are. So let's take a look at that. So the one thing that makes them completely unique, like your DNA, is how many protons that element's atom has in its nucleus. So in this case, if we look at this picture, we have a picture of a carbon atom. And if you notice on the inside, if you count up the red spheres, you'll see that there's 6 of them, 6 protons. So because this atom has 6 protons, and what we've learned about all the elements that exist, we know it has to be in carbon atom. The only element in the universe that has 6 protons in its nucleus will always be carbon. So that is its own unique characteristic, its own DNA, okay? So we're going to start going over to the periodic table. The periodic table and atoms are linked in a way that, makes them very close together. Like they totally are related, and they're interchangeable in a lot of different ways. So what do I mean by that? Well, you just found out that protons are the identifying characteristic that makes an element's atoms unique. On the periodic table, you have something called atomic numbers that go with each element. So if you look there, you'll see that box up at the top, and that picture has a 6 at the top. That's what's called your atomic number. And the atomic number is assigned to that element because that's how many protons it has. Okay? So now when you look at a periodic table from now on, you're going to always know that when you see that atomic number, you can say, oh, wow, that has an atomic number of 6. So I know that kind of atom has 6 protons in its nucleus. So let's look at everything else that's on these element boxes. So that's what these are called. It's an element box. And when you put all of those boxes together in a certain order, that's your periodic table. So starting at the top, okay, the atomic number is usually at the top. Sometimes it might be on the side. Here it's in the center. And then after the atomic number, you have the symbol. The symbol will always be either 1 or 2 letters. If it's 1 letter, it will always be a capitalized uppercase letter, like you see here, capital H. If it's 2 letters, it'll be 1 uppercase and then a lowercase. It's always the way the symbol will look, one of those 2 ways. Then it has the atomic mass, so that's the average mass for one of those kinds of atoms. And then you have the full element name. So here you can see that, oh, okay, so hydrogen has a symbol of a capital H, and it has the atomic number of 1, which you now know means that hydrogen has 1 proton in its nucleus. So periodic table, we're going to decode that for you really quick. So a lot of times when students first start seeing the periodic table, they get a little bit worried, they get a little nervous thinking, they've heard other people say, oh, you're going to have to memorize the whole periodic table. Well, I'm here to tell you most people don't ever have to do that. So what you're going to need to know how to do is decode it. So you need to just know how to use it. It's a tool. So one of the things I want you to learn is that when you have the rows that go across from left to right, that would be called a period. So that's one way you would decode it. You would need to know what a period is. And eventually you're going to find out the period number gives you information as well about the elements in there. Another way that you can interpret the periodic table is to look at the columns. So those up and down parts of it. So you can see where the oval is. A column on the periodic table is what's called a group, or sometimes you might hear it called a family. So that's another thing you're going to want to be able to know. So we're going to be able to go into this all in much more detail and do some cool activities, and we're going to make a model of an atom. These are the 4 things here listed that we're going to do. You're going to label an atom together with me first, because then we'll learn it better. And you're going to need a student activity sheet where we're going to answer some questions and investigate. We're going to label periodic table. And then finally at the end, we're going to build our own atom model with our own periodic table element box that goes with it. So you will need your supply bag that you picked up, and be ready to learn. It's going to be a good time. All right, let's learn about the structure of an atom. This is the paper that you should have in front of you now out of your supply bag. We're going to go through and talk about what makes up an atom and diagram this together. So we're going to start from the outside and work our way in to the atom. So the outside area of this picture of an atom is that purple lavender color. And let's go ahead and label that. If you look on the bottom right, there's a box linked to a bracket that shows that whole purple area. And this is the area we would call the electron cloud. So let's label that here. And with that kind of name, it kind of gives you some information. We know that electrons must be in there. So I want to just put a short little description of what the electron cloud is. And inside of it, it's made of energy levels. So there's actually different levels to the electron cloud. And then I mentioned sometimes they'll call levels shells or orbitals, things like that, but they all mean the same thing. So there's just different areas of the electron cloud. Now, since we're still in the electron cloud, let's talk about those subatomic particles that we've learned are inside of the cloud, and those were called electrons. So there's two to label. We're going to label this one first up here. Okay, so this is an electron. Notice it has the negative minus signal inside of that particle to remind us that an electron has an electrical charge and it's a negative charge. And that's going to be something that's going to be important when we start looking at the investigation that's going to come after this. Now below there we have another electron that has something that we can label there. But this happens to be a special kind of electron that we're not really going to be able to take time to talk about, but you're going to learn about it in middle school, I promise you that. And it's called a valence electron. Okay, so just something for you to have heard that term, and then when your teacher teaches you about it in the future, it'll help you remember it better because you've already heard it at least once. So all a valence electron is an electron that's in the outermost energy level of an atom. So if you look there, you'll see it's on the very edge of our electron cloud. So that's how I would know that I'm going to label that in a valence electron. But again, it's just another electron and it does have a negative charge. So that takes care of our outer portion of this atom diagram. So let's look at the inside. We have two other subatomic particles on the inside. And here we have them labeled. They're colored green and blue. So over here on the right side is where we can label what that area is called. Okay, and it's called the nucleus. So this is the nucleus of the atom. It's always the center. And inside of it, we have protons and we have neutrons. So let's go on to them. So the protons have an electrical charge you've learned about, which is positive. So looking at the picture, we should be able to see, oh, okay, well, I see a plus sign on the green particles. So I know that's got to be representing my proton. So we're going to label that as a proton. And you guys have learned it has a positive charge. And you can signify that with the symbol of a plus. Okay, the other subatomic particle that's inside of the nucleus area is a neutron. So we have a box for that right here. And you've learned that a neutron has no charge, so it would be considered neutral. It's not positive and it's not negative. And you'd see it signified sometimes with a 0 like that. So no charge. So for each atom, you have an element box on the periodic table. So at the top here, you can see that we do have one element box, and we're going to label the parts. Let's go ahead and label the whole thing on that top there first. And so I'm going to write up here, this is a periodic table element box. Okay, and let's start with that top number. The top number I mentioned in the introduction part of the video, that is your atomic number. And you can see this one's a little different. It's at the top of the box, but it's over on one side. A lot of times it's going to be in the center. But that is our atomic number. And then the capital L and the little I is the element symbol for this element. So it's just a way to shorten it, the name. Okay, then below there, we actually have the full name of it, lithium. So that is the actual element's name. And then at the very bottom, you have a number there. That is the atomic mass. It is the average of what a lithium atom would be in this case, 6.94. And you're going to learn eventually it's an atomic mass in units, so atomic mass units. Okay, so now that we've gone over the structure of the atom and we've linked it together with the element box, we're going to go ahead and start our investigation. So you're going to need the activity sheet. We just finished making the atom diagram that looks like this, and you're going to want to have this handy for this first part of the activity sheet that we're going to be working on. So along with that, you also will need the activity sheet that looks like this. Okay, so let's get started by just looking at the introduction it gives us. It tells us if we look closely at the tip of a sharpened pencil, and let me zoom on in here to the picture they're talking about, and you've got it in front of you, you'll see that it's made of graphite. Going deeper, graphite is made of carbon atoms, and deeper still, each carbon atom is made of protons, neutrons, and electrons. In this lesson, you will explore these subatomic particles and their charges. So you've got 3 questions there. 1 and 2 are right on the bottom of this front page, and number 3 is just on the other side. So I want you to take a few moments. I want you to pause the video and answer those questions using both what you've learned and also the atom diagram, okay? When we use things like that, then it helps us remember it even better, okay? So use a combination of both what you can remember and that diagram we made. And then once you're ready, let's go ahead and get started again. So let's go over your answers now that you've had a chance to look at that. So for labeling the carbon atom, now there's a good chance you guys did way more than this answer key shows, and that would be awesome. So I'm hoping that's what you did. So in the inside center there of your atom, that is the nucleus. But you guys learned and you had on your diagram that the nucleus is made of protons and neutrons. So maybe you added that too. Then everything outside of that nucleus, you guys have learned, is the electron cloud, which has energy levels inside of it. And then those little dots in there were representing the electrons. So check to see if you've got that labeling right. I bet you did. For number 2, you had to match the subatomic particle with the electrical charge that would be assigned. So the proton would have a positive charge, the electron would have the negative charge, and the neutron is neutral, meaning no charge. And then finally for number 3, they wanted you to say whether or not those 2 subatomic particles that they give you, if you place them next to each other, would they repel each other or would they attract each other? So the 2 protons and the 2 electrons, they both have the same exact charges. So 2 protons, they're both positive, they're the same, they're going to repel, okay? Same with the electrons, except they both would have negative charges. But you put 2 negative charges to each other, they would repel. But the last one, proton and electron, you've got 1 positive, 1 negative, they're going to attract each other. Remember that whole opposites attract. So that's how you would have filled that in. All right, so let's get on with the actual investigation part where we get to actually manipulate some things and see what happens. So the question we're going to investigate, you can see there along with on your activity sheet, is what makes objects attract or repel each other. So we're not just going to be looking at individual atoms and subatomic particles, we're going to be looking at some pieces of matter. So the pieces of matter that you're going to need for this first part, this first procedure, is one of the plastic strips, okay? It tells you for materials you need a plastic grocery bag and scissors, but I've already cut up grocery bags for you guys. So you should have 2 plastic strips in your material bag. So you're going to want to grab one right now. You can go ahead and grab the other one actually. So I just want you to take a look at them, okay? They're just 2 regular plastic strips that were literally cut from a bag, okay? And they just hang there like they're supposed to, right? So you're going to put one aside right now. We're just going to work with one. So if you look at your procedures, it tells us you're going to hold the plastic strip firmly at one end. Then you're going to grasp it with your other hand, so your thumb and your fingers on either side. And then you're just going to pull your hand across the strip 3, 4, maybe 5 times. Just do that a few times, okay? And then allow the strip to hang down. And then you're going to bring your hand back towards it, and you're going to see what happens, okay? And here's what happens. That was not a very good representation, but hopefully you can see clearly, or you're getting it better on yours. Okay, you can see a little better there. So what's happening there? As I bring my hand closer, you'll start to see, yep, the plastic bag strip starts to move, okay? So it meets up with my hand. So the question is there, why is that happening? So you have a table on the next page on the other side, bottom of 256, where you can fill in these observations. So first of all, what did we see after we did this? Did they attract or repel each other? So eventually you can see they attract, okay? That strip keeps going towards my hand all by itself, okay? So the correct response for our observation would be that it was attracting, okay? But why did that happen? So if you look on the bottom of your activity sheet, you've got these visuals right here. And these are really good at being a visual to explain what's happening, but I'm going to talk about it too. So before we did any of the running our fingers down the strip, we had a neutral piece of plastic bag and we had a neutral hand, neutral skin, okay? So you can see there it's showing us the plastic and the skin, the pluses and the minuses for the protons and the electrons, and they were equally distributed, same amount, and so they were neutral, okay? But after we ran our hands across the strip, what happened is some of the electrons from our finger atoms and our hand atoms were actually transferred to the plastic, okay? So we lost electrons from our hand and gave it to the plastic. So now the plastic is charged with a negative charge because there's more electrons than there are protons in that strip. And our hand is actually positively charged because we lost those electrons, gave it to the plastic, and now we have more protons, okay? So we know protons are positive, electrons are negative. So after we've done all that, those transferred over, that's why you end up having them come together because they're actually being attracted to each other. So what you're going to want to do is in that table, you're going to write down that in your own words. And so you're going to want to pause it if you need to, because then we are going to be going straight to part 2. Okay. So for this part, we're going to do kind of the same thing. You can use the other strip if you want to that you haven't really messed with yet. Okay. So it's just hanging around here. And you're going to want to have your desk or your chair. Or I'm going to use a ruler so that you can see it because you really can't see my desk and everything with this position. So this is going to be my piece of furniture here in a moment. But we need to do the same thing. We need to charge up this by transferring electrons to it. Okay, so we're going to run our fingers down this again. All right. Okay, it's hanging there. Okay, and I'm going to bring the desk here, the ruler, and see what happens. And you can see that the same thing happened. Let me get closer. I'm going to try to charge this up a little bit more because that's not doing it as well as it usually would. Okay. There we go. It's working a little bit better. All right, so I had to modify a little bit because the ruler just wasn't doing the trick. So I've lifted up this pedestal that I have because it's kind of like a desk. So we're going to try this again. So we should have our strip of plastic. Okay, I'm going to make sure it's still really charged up by doing this again. And I'm going to just start to bring it towards the desk. And there, now we can see that way better. So let me do that one more time. You can start to see it leaning in, and there we go. Okay. So same kind of thing. You're going to go ahead and make your observations and put them in that chart. Okay. Now the last part we're going to do, let me lower this back down just a little bit, is you're going to actually need to have both strips. Okay. So we're on procedure part 3. So 2 pieces of charged plastic. So if you remember the beginning when I showed you the 2 strips and what they would look like, they're just both hanging there right next to each other. I've been doing a lot to charge them up, so they probably won't do that anymore. No, it doesn't look like it. But let's go ahead, in case you've only been using one strip, make sure that they're both charged, okay? In this very technical scientific way of transferring electrons, right? Okay, so have them both charged, okay? They're both hanging out here, and we're gonna try to place them, put them next to each other, and let's see what happens, okay? So I'm bringing them closer. And as you can see, they don't want to cooperate, right? So I'm bringing them closer again. And they're like, no. In fact, they want to go towards my arm, okay? Because they're trying to get to an opposite. Right now, these are both strips are negatively charged because we transferred electrons to both of them. So more electrons than protons, you have some kind of negative charge. A negative is larger, so it's going to end up being negative. All right, so make sure you finish that table up, and let's go over that and summarize together everything that we learned. So if you take a look here, the charged plastic and charged skin that we started with, the plastic ended up negative because, as I told you, we transferred electrons. The skin ends up more positive because we lost the electrons, so now those two are opposites and they attracted each other. For the plastic and the desk, which I try to use a ruler first, but once we did actually use the pedestal as a desk, the plastic was negatively charged because we, again, transferred electrons to it to make it negative. The desk was still neutral, but it ended up being more positive near the plastic because those extra electrons on the plastic repelled the electrons that were in the desk on the edge, and it left protons there. So now they still did attract. And then finally, that last part when we had both strips of the plastic, they were both charged. We added or transferred electrons to both of them. So they repelled from each other. You could see you try to start bringing them together, but because they both had extra electrons, they're both negatively charged. They're like charges. They're not going to attract. They're going to repel. So it's like they kept just trying to get away from each other. All right, so for the last part of this is my more favorite part. You're going to need to get the balloon that's in your materials. And then you're also going to make some kind of little bits of confetti. So to do that, real easy, and you can do exactly what I did. You can take the activity sheet we've been working on and just go to one of the bottom parts, okay, and just cut a strip off. So you can see I cut just maybe an inch tall strip off, and I didn't even use all of it, but I just cut it up into little pieces here. So let me lift this up a little more. Okay, so here you can see there's my little pile of confetti. Okay, so you're going to need to have the little pieces of paper as your confetti, and you're going to need to blow up your balloon. Now the balloon is a latex balloon, so in case you're somebody that has any kind of latex allergy or gets irritated by it, you might want to have your parent or brother, sister, or somebody blow it up for you, okay? Or you could get another balloon if you've got some balloons that aren't latex, okay? But assuming you've paused it and you've gotten what you need to, or you could just watch me do it too, but it's always more fun when you can do it. You're going to grab your balloon, and if I put the balloon over the confetti right here, you can see nothing really happens, right? Everything's just sitting there minding its own business. But we're going to transfer electrons like we've learned to do by rubbing this against our clothing. Or you could rub it against your hair if you don't mind your hair sticking up after that, okay? So I'm going to transfer all kinds of electrons. Now let's put it right over it again and see what happens. And you just saw some of the confetti started flying away, literally. Okay, so it's kind of fun. Let's do that again. Okay. Woo! That one's like dancing. Oh, there we go. Okay. And again, it's because the paper, okay, is originally neutrally charged, but because I added so many electrons to this is a very negative charge. When I start to put the balloon next to it, the electrons that are in this neutral little piece of paper are repelled because there's so many electrons over here. So they move over. So the edges of the paper that are closest to the balloon end up being positively charged because it repelled the electrons. And so then it gets attracted to the balloon. Okay, let's do it one more time just for good measure. And there we go. They start dancing around. So whenever you find yourself getting shocked, here you can see some of it stuck on there. Now you know what's happened, okay? You transferred your electrons somewhere and you ended up coming across something that was more neutrally or positively charged, and voila, you get a shock. So, all right, next thing you're going to need is your periodic table, okay, which is also in your materials bag. And you're probably going to want to have some colored pencils as well, any colors that you would like, okay? All right. We've got our periodic table now in front of us, and you need to at least have a pencil. You might want to have some different colors. You're going to see me use different colors, but that's completely up to you. And if you do use colors, you can use whatever colors you want. So here is the beautiful periodic table of the elements. So first thing I want to mention is we could very easily, instead of saying periodic table of the elements, we could say it's the periodic table of the atoms, because as you guys have now learned, elements are made up of a single kind of atom, okay? Every element has its own distinctive atom. So let's talk about the structure of the atom first, okay? So for the basic atom, we could just say that we've got on the inside, we'll work from the inside and go out, we have a nucleus, okay? And I'm just gonna put one giant little oval around that, okay? So the inside is a nucleus, and you guys have learned it's what is made up of protons and neutrons. Okay. Then on the outside, everything other than the nucleus, we basically have the electron cloud, which is why I made kind of a cloud looking thing. Okay. So I'm going to label that electron cloud. And the name tells us electrons can be found in there. Okay. We never know exactly for sure where they're at any one time because they're constantly moving. But we have a good idea, like we have probabilities on where they're at in each energy level of the electron cloud. Now, to get a little more specific with what we just said, let's go ahead and make ourselves a different kind of atom model that shows we know what goes in that nucleus and that electron cloud. So I'm going to switch colors just to distinguish it. So for my nucleus, I'm going to put a P and a plus for positive protons. And then I'm going to put an N and a 0 for neutral neutrons. Then I'm going to draw a circle like this. And this is representing an energy level inside the electron cloud. And I'm going to put these two little dots and an E and a minus to represent those are my electrons. So that's a whole nother type of model we can look at to be able to understand atoms better. So let's relate atoms to our periodic table. I'm going to go ahead and switch the color again. So we have here our element box, which we have been talking about. And the main thing I want you to really remember from this session is that atomic number there right at the top, okay? That atomic number is always going to tell you how many protons that element has in its atoms. So this example we have on the top, silicon, if it has an atomic number of 14, then we know a silicon atom is going to have 14 protons, because that is what gives it its identity, okay? So let's write that next to protons. Unique identity. Just like you have DNA that's specific and unique just to you, an element has a number of protons in its atoms that's specific to that element, okay? Now you guys have learned protons are positive. I want to just throw something else in there that you're going to learn eventually and it'll come in handy. This atomic number is also the number of electrons that are in this type of atom when it's a neutral atom, meaning it has the same number of protons and neutrons, okay? So that can come in handy. You'll learn stuff later where it gets a little more complicated, but you're always going to learn first that your protons and your electrons you can get from that atomic number, okay? Okay, so what I want to do next, I'm going to switch my color again, and we're going to decode the chart even just a little bit more, and we're going to label what the rows and the groups are called. I'm sorry, the rows and the columns. So I'm going to pick the fourth row. So if you notice here, we've got these numbers going down the left side, okay? That's what you would call our row number, or what you now know, maybe you remember from that first video of this session, that is called the period number, okay? So I'm going to just outline one row like this in a color, okay? And a row on a periodic table is called a period, okay? Now, the interesting thing about periods is this is another thing you're going to learn eventually. It tells us even more about the atoms in there. This number 4 tells us how many energy levels those atoms have, okay? So any of the elements in here would have 4 energy levels in its electron cloud. If it was in the first period, like at the top with hydrogen and helium, those are the only 2 in the first period by the number 1, they only have 1 energy level. All right, so let's switch colors up and we're going to talk about the columns now, okay? So the columns are the up and down portions that you can see right here. So I'm going to go ahead and outline the second one. And instead of calling them columns on the periodic table, we would call them a group. Now there's another word you can use also, and that word is a family. Okay, so the columns that go up and down, you could either call a group or a family. And you're going to learn way more about different types of families on the periodic table later on in middle school in 8th grade. So something to look forward to. Okay, so those are the basics of learning how to start interpreting a periodic table. And the only other thing I want to mention before we move on to our last bit is which atom we're going to be building for our model, which is what we're going to do to wrap up this session. So the atom that we're going to be building is this one right here, okay? So the element is argon. So after everything you've learned, I bet if we were in person together, I could ask you, okay, if argon has an atomic number of 18, how many protons is it going to have in its nucleus? And how many electrons is it going to have? And I bet you guys would be able to tell me from what we learned over here that argon is going to have 18 protons because the atomic number is 18. And it's also going to have 18 electrons, since I can tell you it is going to be the neutral atom version of argon. So you're going to want to get the instruction booklet that you've got that has all the instructions on how to put it together. And then you've also got the pieces of cardstock where we're going to be cutting and coloring and all that good stuff. So get all that ready to go and let's make a model of an atom. We have made a 2-dimensional model atom. We have labeled our periodic table. We got to do some experimentation to see how matter interacts based on charge changes. And now the last thing we want to do in this session is make a 3-dimensional model of an atom. So this short little video clip is to just get you prepared so that you know what to expect during this model making. Okay, so first thing I want to go over with you is the materials that you're going to need out of the supply bag that you've got. Okay, so I've got them listed here, but I'm going to show them to you as well. You're going to need to have these instructions. Okay, these instructions are really good to refer to as I'm also showing you things. Okay, now when we're going to start putting them all together, I'm going to have it to where the camera is going to just be on the materials that I'm putting together and cutting and all that and handling with my hands so that hopefully you can get a clear idea of what you should be doing. The second thing you're going to need is the templates. So those are the 4 pieces of paper that look like this, okay? It's a thicker cardstock paper. This is what's actually going to end up becoming the atom model. Okay, you're also going to need some kind of color. So you should have colored pencils in your bag. You're welcome to use markers in addition or instead of. When I was doing one beforehand to see how it would work, the markers look really nice on it. So if you have those and you want to use them, go ahead. But if not, you definitely should have your pencils. You're also going to need scissors. Okay. Now these little ones can be difficult to work with if you have larger hands. Like I do have pretty long fingers myself, but there's some parts of the model where it actually is more convenient to use little ones. So if you have a larger pair at home anyways, you might want to have those on standby for when we cut out the bigger pieces. But for the little stuff, sometimes it's easier to get in there with the smaller scissors. Then you will need your little glue bottle. You will need the roll of tape. You're going to need the string that should be in your bag. There should be 2 pieces. And then this is not absolutely necessary, but I did include a plastic utensil. And this will come in handy when there's these little parts that we need to score or kind of weaken them a little bit with a line so that they're easier to fold. So you do have that included as well. So before you actually get started with the next video clip to start making the model, I would make sure you have all those handy, okay? And a nice organized space will help too. So let me just make sure you know, to do this model, it definitely takes some patience, and you're going to have to pay attention to the details. And I'm going to try really hard to make sure I, give you a heads up and bring your attention to things that you need to be careful of. You might want to look into breaking up making the model into your own little stages. That's what's really nice about having things on video like this, is you can come and go as you need to. And don't hesitate to ask somebody for help that you might have in the house, whether it's a older brother or sister, or mom, dad, stepmom, stepdad, aunt, uncle, whoever. If you're having a hard time, maybe show them what you're trying to do and they might be able to help you. Okay. And let me show you what the end result's going to look like. This is going to be your model atom. Okay. So you can see it turns out really nice in a 3-dimensional model. Okay. And then we have a 3-dimensional element box that's going to go with it as well. Okay. So it's really worth the time and the trouble. And I tell you, it will really help clinch your learning, solidify it when you're putting something together like this, because the whole time we're working on it, you're thinking about what we've learned and where the electrons are and all of that good stuff. So I hope you are ready to go on it. Get your stuff together and let's get this made. Let's get started making our model. So you should have the instructions right here. You're going to need to have those handy the whole time in case you're not understanding something I'm trying to show you or to say, so that you can look at the pictures here and read them, okay? And then you should have all the materials I already went over with you. It does say to have a ruler. It's not absolutely necessary. There is a part where you could use it, but you really don't have to have one. All right, so you're going to go ahead and flip to the back of that first page, and this is where we're going to start. Okay, notice it has the instructions right here. There is also an assembly video on YouTube if you wanted to go and look at that. It goes pretty quick, but if you wanted an overall idea, then you might want to watch that. It's got a really robotic voice, but it does work. So that option is there for you too. So we have our instructions, and then you're going to need this paper first, the one that says first and second shells. Okay, so let's get that ready. All right, so we need to color in the correct number of electrons for the first shell. If you remember, we are doing the element argon, and I can tell you that the first shell does have as many electrons as possible, which is going to be 2, okay? So it's time for you to decide what color you want to color your electrons, okay? And it doesn't matter, it's completely up to you. I'm going to use a yellowish color, but again, you use whichever ones that you want. So we're right here where it says first shell, and these are our electrons. They're on the outside in the energy levels. And you'll notice, okay, I said that you can fit 2, and there's 2 and 2. Well, these are going to end up being folded together so that we have them on both sides. So that is why it looks like we're making more than what we actually need to. Okay, and you don't have to do this part, but if you have a darker pen or pencil, it's kind of hard to see where they have the E minus, but that's what's supposed to be there. So I like to just add that there so it shows up a little bit better. So you can do that, but you don't have to. Now you could also even shade in the whole energy level if you wanted to with another color. Completely up to you. It is your model, so I want you to do it the way that you would want. Okay, so next thing we're going to do is we're going to need to go ahead and cut out our first shell here. Okay, so we're not going to worry about the second shell at the moment. What I want you to do, you're just going to cut out this square right here, and then from there it makes it way easier to cut in all of this. Okay, so go ahead and pause the video and take some time to cut that. You should now have that rectangle cut out. Now before you start actually cutting the two parts of our first shell, I want to point out something. Notice I put some pink highlighter around these, and that is to show you what to cut and what not to cut. So notice I start here where this indentation is. You're not going to cut right here. Do not cut through the two circles, okay? So you'll cut up and you're going to go along the triangle. Don't cut that off. You're going to come all the way around, down along the triangle and up until you get to the point where the two circles touch. Don't cut through there. And then you're going to cut all the way around. And I'll tell you, I had to redo one of these because as I was talking the first time trying to do this video a second ago, I accidentally cut off one of these bottom parts. And these are super important because these are how we're going to connect the shells together, okay? So go ahead and get your scissors and you're going to just cut around where I showed you. And by the time I'm done cutting, if you still need some more time, then that's when you're going to want to pause the video, okay, and then just restart it once you're caught up to where this is cut. Now the paper that these came off of, that we cut this out of, make sure you hold on to that because that's got our next shell on there we're going to need eventually, okay? So this is what you should end up having once you are done cutting, okay? So what we want to do now is right where those two circles join up, we're going to fold it right there, okay? And you should see they end up being back to back. So now we have two sides, okay? So that's the complete shell or energy level. All right, I want you to go ahead and before we start to glue, I want you to, where those triangles are sticking off, okay? There's a black line there and a black line here. You're gonna cut right up that to the circle. And you can actually even cut a teeny tiny bit into the circle. Okay, I have found when it's time to put these together, it's easier if there's a little extra room there. Okay, so you're gonna cut just a little extra past the line. And then you're gonna do the same thing on the other one. Going just a little past the line, okay? All right, and once you've done those two cuts, you're going to unfold them again, and we're going to go ahead and glue these two together. Now, since this is regular glue, okay, since those glue sticks don't always stick real well, it doesn't take a ton, okay? So I put a little bit on there, and then I kind of try to spread it out, thin it out a little bit, and then you'll just press these together, press them down good a few times, okay? And then you're going to just set that aside in a safe spot because we'll end up coming back to it later, okay? All right, so we're going to go to the next page. So we just got done doing this part here. So now we're on this page of our instructions, okay? So we need to get the nucleus and the information tag for the element. So we need the page that looks like this, except this isn't the element we're doing. They just gave this as an example. But you'll find one that looks just like it for argon. And it looks like this. Okay. All right, so I want to tell you for this tag that's going to end up being the 3D element box, you can color this however you want, okay? I am going to point out a few things to you as we make the nucleus together, but this you can truly add any color that you want or not add color, it's up to you, okay? Right now, we're going to focus on the bottom portion, the nucleus, okay? So again, we're doing argon. So you can color this any color that you would like, once again, but we do need to figure out how many protons and neutrons are going to go in the nucleus of this atom, okay? So I taught you earlier that you can find the number of protons super easy if you see them on the periodic table, if you see this element. So I'm going to just grab one of the periodic tables I have and show you. Here is argon. And remember I told you that the atomic number that's at the top of the element box is your number of protons. It's also the number of electrons usually, okay? So that means if argon has an atomic number of 18, then we're going to have 18 protons, okay? So you're going to use a pencil or a pen or whatever you like, and we're going to fill in right here the number 18 to show the nucleus of an argon atom would have 18 protons. And notice we have the P+, okay? Because we know that protons are positive. Okay, the other part of the nucleus is the neutrons. So we need to figure out, well, how many neutrons do we have? So let me share with you real quick. There's an easy way to do that. So because the nucleus is only made of protons and neutrons, once we know how many protons there are, and we know how much mass one of these argon atoms has, which is right here, 39.948, then if we just subtract our protons from our total mass, whatever's left once we get rid of those protons, we know are the neutrons. So you might wonder, well, how come that's all the mass? What about all those electrons? Well, that's what's interesting. Electrons have so little mass that they don't make a difference in the mass. So we don't even count them. We only count the protons and the neutrons, okay? So what we would do is we would round the 39.9 to 40, okay? And we would just subtract the 40, or subtract the 18 from the 40, okay, to figure out how many neutrons that we are going to have. And so that would leave us with 22, okay? And if you wanted to check your math, you would say, okay, 22 plus 18, does that give me 40? And yes, it does, which is our mass, okay? So you can go ahead and you can color these anything that you want. So let me show you what I mean. Let's say for neutrons, I wanted to go with blue. So I can shade this blue. And for protons, I'm going to go with a pinkish color. And you don't even have to do this. This is just if you want your model to have a little bit of color. Okay, so what we need to do now is cut these three parts out, which reminds me, you can also color that too. So these three pieces are going to end up going onto where our first shell is in the middle, because that's where the nucleus would be. So you can see here it tells us nucleus part A is going to fit on here, and nucleus B and C is going to fit here. And there's B and C. And you might be wondering, well, how are we going to fit both of those and still see it, which is a really good question. And right here it tells us we're going to fold these actually in half and glue them together, okay? And what do I mean by that? Well, if I look at my finished model here, you can see this is the first shell on the very inside, and you can see how we're going to do that there, just to give you a heads up, because I know that can be kind of like, whoa, how is that going to work? Okay, so right now I want you to cut out these three pieces, okay? And once you do that, go ahead and start the video back up, but take a moment, pause, and cut these three pieces out. You should now have part A, B, and C cut out just like this. And then here's our first shell. We're going to end up attaching these here in a moment. What I want to show you is you're going to turn the page from where we were, and you should now be on this page right here where the scientist up here is saying fourth, okay? So what we're going to end up doing now is we're going to add on part A inside of that first electron shell, okay? Notice it says A, so the one that we have that's A says argon on it. So that's going to go on part A. And then it's going to get a little bit trickier there where we're going to fold these and paste them on the other side. So let's just go ahead, and you should have your glue, and you're going to grab part A that says argon, capital A, little r, and you're going to just spread a little bit of glue on there. Again, it doesn't take a whole lot. The stuff will stick pretty well. And then make sure you've got the right side. It says nucleus part A in the center. And you're just going to line that up on the inside and press that down. Okay. All right, and then you're going to flip that over, and we'll let that sit and dry for a little bit longer. And we're going to need parts B and C. So this is where the plastic utensil can come in handy for what we call the scoring. Okay, so let me show you what I mean. So you can see the black line that goes straight down the middle of each of these circles. That's where we're going to need to fold. And to help fold it more evenly, what you can do is just make sure you're holding down that pretty well, okay? And then you're just going to run that right over it with the more of the rough edges. And that would be scoring, okay? And then you can do that with the other one. Again, you don't have to do that. You can still fold it. It just won't fold quite as easily, but it will still fold, okay? So now that you have those folded, you're going to fold them up, okay? So we're going to fold it to where it's like we're trying to cover one side up. So go ahead and try to fold it in half like that, okay? So you can still see the stuff on the inside there. And do the same thing with the other one. Okay. And then kind of release it after that. So once you release it, it looks kind of like a crispy taco actually. Okay. All right. So back to our first shell, nucleus parts B and C. Okay. So what we're going to end up doing is end up gluing them like this. So it gives us that 3D look. All right. So what you should probably do first, this is how I did it before, we're going to glue the two parts together before we glue to the shell, okay, the nucleus. So I'm just going to put a little glue on one of them. Okay, so I put a little bit of glue right there on my proton side, and now I'm going to push those two together like this. And then you might just want to hold on to it. Just kind of pinch it for a little bit. And if you let go, it should stay together. Okay, so you can see on either side. Okay, go ahead, put a little bit of glue right here. This is where that whole thing's going to go now. And then press this down. Okay, and maybe just hold it down for a few seconds. And then we're going to set it aside in a safe place. So you should have now a completed nucleus and a completed first energy level. Yay! And let's get back to our instructions. So we just finished with this page. So we're going to flip to the next one, which looks like this. Okay. So every element on the periodic table except for hydrogen and helium will need a second shell. So that definitely includes argon then. So we're going to go ahead and make that second shell. So the second shell will be on the same page where we cut out that first shell. Okay. So the page you should have looks like this. Okay. So go ahead before we cut and start gluing and everything. You're going to want to color your electrons, assuming you want them colored. If you don't, then hey, no big deal. So I colored mine again yellow, and I put the E- in there. And we already have 2 electrons on our first shell, 1, 2, and we know there's going to be 18 total. So if this won't give us a full 18, we know there's going to be a third shell. And it won't, because if we count here, we can fit 1, 2, 3, 4, 5, 6, 7, 8. And that is the way that works. You can fit 8 electrons in the second shell. And remember, these stand for the same electrons because these are going to be folded over. So if you want to color those, please go ahead and do that now. Okay, and then after that, you're going to cut these out the same exact way we did that first shell. So I want to just point out, remember, you don't want to cut that off, okay? And you don't want to cut these separate from each other. You want to just be able to fold them over. And I'm not going to highlight all of it, but I'm just trying to point out again, make sure you don't cut these off, okay? You're going to cut all the way around the edges, all right? So let's go ahead and do that. And remember, once you get right here, you don't want to cut all the way through. That's where we're going to fold it and keep it connected. Same thing here, you go up to that indentation and then stop, and then finish on that other side. All right, so you should have this right here. Okay, if you're not done cutting yet, then I would go ahead and pause the video until you've got that all cut and ready to go. Okay, so what you're going to do now, we're going to fold this over just like we did that first shell, okay? So that then you have both sides of them look like they're complete now, okay? And then we're going to go ahead and we are going to glue these together. Although actually when I made this earlier, I went ahead and cut out the center first, and I do actually recommend that. So let me show you what I found to be the easiest way to cut these centers out, okay? So keep them apart like this, and you're gonna slightly bend this, and you can see where it says cut out center. Grab your scissors, and you're going to, make sure you watch this before you do it, you're gonna just cut one portion there in the middle, okay? So see how I cut that little hole, but I didn't cut through my shell. Because once you cut a little hole like that, then you can get those scissors in there to at least cut straight across like there and there. And then what I do is I break it up into like little triangles that are inside there, okay? So I'm gonna cut them like that. And then that gives me a way to get around the circle. This is one of those times I mentioned where you just have to have some patience, okay? And take your time. No reason, it's not like this is like due in the next 5 minutes, right? This is just you learning for learning's sake and hopefully having some fun while you're doing it. Okay, so I've got that one cut, and then we need to do the same thing here. So again, I'm gonna bend it like this, not all the way, but just enough where I can get my scissors in there and get just that little bitty cut, okay? Now, if you have a hole puncher or something, you could always punch a hole in the middle of it and use it that way too to make these cuts. I'm sure you guys could come up with all kinds of creative ways to get this done. Okay. So we have those cut out, so that's our second shell. Before we glue the two rings together, I want you to go ahead and remember before how we cut on these black lines. This is how the shells are going to connect later. So cut up and then cut a little bit into the shell, but not all the way. Okay, just cut a little bit extra there. So do that on the top and the bottom of one side, and then go to the other side and do the same thing, top and bottom. Okay, and once we have that done, now we're going to glue these together. So I would just put the glue on the circle part. Don't use too much, or when you flatten them down, it's going to get out of there and it's going to make a mess on you, okay? And it's always good to kind of smooth it out a little bit. Okay, and once you first get it on there, if you feel like you need to shift it a little bit, you can do that. As long as you do it quickly, you can shift it, okay, to where it looks more even. And ta-da, there we go. We have our second shell. Okay, so go ahead. We're going to set that aside along with the first shell we made. So this is what we should have so far, okay? And let's go ahead and flip our instructions page to the next one. Okay. And it says if we have a third shell, now we're going to make that, which we do have a third shell because so far we've only filled in 10 electrons in our shells, and we know we need a total of 18. So you are now going to need this other paper here, okay? This should look really familiar. It's just larger, and you notice it holds way more electrons, and that's how those energy levels work. As you go further out from the nucleus, it's capable of holding more electrons, okay? So before we cut these out, I want you to go ahead, and if you have been choosing to color these, then you're going to go ahead and color the electrons. But here's the key. we only need, if we already have 10 electrons, because we had 8 in the second shell and we had 2 here, so together that's 10. We need 18. That means we only need 8 more, right? So here's what you're going to do. We're going to kind of skip around and make it even, okay, the way they would fill these in. So we will use these 2. So there's 2 more, and then we're going to skip the next 2 on either side. Skip again. Skip again. See, 1, 2, 3, 4, 5, 6, 7, 8. That's all we need. Okay, that's all the number of electrons that would go in that second one. Okay, so you're going to do the same thing on the other side, because remember, these are representing the same electrons that we just made, just so that we can see them from both sides, just like you would be able to with a real atom. That's why we want to make it a 3D model. Okay. All right, so we're on the third shell. Okay, I've already started cutting. This is going to be exactly the way the last one was. Okay, so you notice here I've already cut out the center. Just once you've got this cut out, make sure again that you do not cut off those triangles on the top. Okay, so I'm going to still cut out this other one. So remember how we started it, where we just kind of fold it gently. We don't hard crease it or anything, but we fold enough where we can get those scissors in there just to make ourselves a little hole like that. Okay. Once you've done that, you can get the scissor tips in there so that you can start to cut from about the center to the shell in like these triangle formations, kind of like you're making slices of pie. Now this is a bigger shell than the last one we had, so it's going to take a few more triangles. Okay, so once you've got it like that, you can start cutting around those edges. So you are going to need to do that on both of the circles. Okay. So if you're not done cutting out yet, I would pause the video, okay? Now once you do have it cut out, we do need to go ahead and we're going to cut these 4 lines here, like we have on the others, and going a little bit past. Okay. And then we're going to flip it over because we need to add some glue to one side of it and then fold this together. And I just kind of like to try to spread out that glue a little bit. Okay. All right, we're going to set that aside for a moment. And we are going to be on this page now. So this is where we're going to actually start to get to put our shells together. So it starts to look something like this. Now this one has the maximum amount of shells. We're only using 3. So what we need is what's called shell anchors, okay? The shell anchors look like this, and you've got another template piece of paper that has a whole bunch of those. We only actually need 6 of them, but they are very important because they are how these things are going to be able to really stay together like this, okay? So go ahead and grab those. It's this paper here. And what I recommend you doing, we're just going to cut out a group of them because we don't need all of them. It came like this, okay, in case you do one of the really big atoms. So we're going to need to have about 6 of them. So I'm just going to cut around 6 of them like this. just makes it a little bit simpler when you have only what you really need. Okay, so before we start cutting them out, this is where the scoring really comes in handy. This is a part where you definitely want to use this if you can. Okay, now this is also where if it's easier for you, you can use a ruler, but it's not absolutely necessary. Okay, so we're going to need to score on, I'm going to go ahead and mark one so you can see. We're going to end up folding on this line once we've got them cut out, and these lines. Okay, so for each of these anchors, we're going to need to score 3 times. Okay, so what I'm going to do, I'm going to go through and just score the middle section first. Okay, like that, and then just zoom over to the next one and do the same thing, because then you're kind of already in that mode. So I'm just taking those edges along that long line in the middle of the anchor. And it doesn't look like it's doing anything, I know, but it really does. You can kind of see the indentation you're making. It will help when you have to fold these little bitty pieces, okay? So now I'm going to do it for my diagonals here, okay? So this is one of those times too where you got to try to just pay attention to detail. Okay, so once we've got them all scored, now it's just a matter of cutting them all out. So get all of them cut and then we will go from there. We've got our anchors cut out now, so I'm going to show you how to fold those in a moment. What I want to point out is we're on this page here. Okay, so we're going to end up placing our first shell, which is the one that's got the nucleus, inside of our second shell, and this is where these cuts that we made come in handy. Okay, so let's go ahead and do that really quick so you can see how that's going to work. So again, you should have your first shell and your second shell, and it tells you on the bottom, first shell, second shell. Okay, so kind of bend these like this a little bit, opposite of each other, and it will help you when you first need to try to get them on. So you're going to place this on the inside, so you're going to need to tilt it just a little bit to get those folds. Again, this is one of those times where you got to have that patience, okay? So I've got the top part on. Now I need to do the same thing with the bottom. So you will have to bend just a little bit to get that through until it's in between those 2 cuts, okay? And here you go. So once you got it in there, you can kind of try to straighten it out the best you can so that it's directly over where that second shell is, like that. Okay. All right, so now that we have our first and second shell together, look at what you've done. It's awesome. Go ahead and set that aside, and we're going to need to put anchors that we just cut out alongside here to actually glue them together, okay? So let me show you how you're going to fold these. I'm going to use that one where I drew those lines because that's where the folds are going to go. So you're going to end up folding the middle line first, so that longer line, okay? It looks almost like you're making a paper airplane. Okay, like that. Then the little flaps, the little lines are going to be folded outwards. All right, so we need to finish folding the anchors. I did realize we only cut out 6. I actually needed to tell you to do 8, so you will need to have a total of 8 of these anchors. So let me show you again. Remember, you're going to fold down the middle first, the longer line. So you're just going to fold that in half like this. And these are very tiny, so they can be hard to deal with. Once you've got those folded, then you're just going to fold out those smaller little flaps like this. And then when you're done, it should look like this, where you Looks kind of like, to me, it looks like a paper airplane. Okay, so we need to do that to all of them. They don't have to be perfect. As long as they're generally folded the way I'm showing you, they will work. You'll see what I mean. Almost there. Okay, so now we've got all the anchors, and we had already put the first shell and the second shell together. So again, how these are going to work, we're going to put glue on the inside of them, right in here, and on either of these flaps, okay? Then you're going to go to where the two shells join together, and first you're going to take that larger flap and you're going to fit it over that triangle portion that was on the top of the shells. And then you push it forward onto the shell like that. Okay, so it's just another support to make sure these actually stay together. Okay, because right now they're just fitted by sliding onto the paper. So go ahead, grab your glue, and I start by just putting a little bit right in the center here. Okay, it'll spread out once you squeeze it onto the shell, and a tiny bit here, and a tiny bit there. So now I'm going to, you got your two little flaps here, okay? That's going to go towards the shell there, and it will fit right on this portion here, okay? So you will have to hold it just for a few seconds, okay? Like I'm doing here. So it's like you're pinching it along the first shell and pushing it towards the second shell. And then we're going to need to do the same thing on the other side. So grab another one of your anchors. Start by putting the glue in the center, a little bit there, and a little bit there. Now we're on the opposite side where we already put this anchor. And again, we're going to just slide it over the top of that first shell and against the second shell, and just hold them together just for a few seconds. And there you go. Should be sticking pretty well. So we need to do that on the bottom portion too. So we need to put an anchor here and an anchor here. Oops. Okay, at this point, our first and second shell are attached in a pretty sturdy fashion, okay? So now we need to do the same thing, but now we need to put this first and second into the third, okay? So what you're going to do is, once again, we need to kind of scoot these like this. And just pick which side you want to get on there first and just tilt it however you need to. And then we need to do the other one. So this is why it's good that we did this on this thick cardstock paper, because it can take you having to bend it back and forth to position it just right, okay? All right. So straighten that out as much as you can. And now you're going to need to put an anchor here and here, and then here and here, okay? I almost lost it. So you see how much effort a 3 shell atom took. Can you imagine doing the ones that have way more? But they would look really cool when you were done. Okay, our last anchor. We are in the home stretch, meaning we are almost there. So hang in there. So this is going to be your last chance to add any color, anything you want to the 3D element box, because once we fold this to make it 3D, it's going to be really difficult to try to color it. So I really recommend, if you know you want to add some color and stuff to it, like I did, then you're going to want to go ahead and do that before we move on. And then you're going to need to cut this out, okay? So this is one big piece. Once you've cut around all the solid lines, make sure you do not cut where it says glue tab, because that's where we're going to be folding and gluing to get this all together, okay? So once again, to make this easier, we're going to score certain areas where we're going to fold, especially the glue tabs, okay? That's the part that is going to be crucial to be able to fold as good as possible. So I'm just going to go along each one of the glue tabs along that black line. Okay, and then once you've done that, we're going to also have to fold on either side of where it says argon. So I'm going to go ahead and score along those two black lines. Okay. And then let's go ahead and just do the same thing all the way across the bottom of all 3 boxes. And the top. All right. So I want to point out, of course, it's got our element symbol, capital A, little r. It's got the name argon. That's our atomic number 18, which we know shows us we have 18 electrons. Notice these numbers I printed here, 288. That's called the electron configuration. So that's telling you how an argon's atom is built with its electrons in its energy levels. So because there's 3, that means there's 3 energy levels or shells. So if you look here, nucleus, and then 1, 2 in the first shell, and if you counted these, you would get 8 in the second shell, and if you counted these, you would get 3 in the third shell, okay? All right, so now that we've got that together, let's go ahead and start making our folds just to get it primed, and then we will start folding where the glue tabs are, and then we'll add our glue, okay? So I just kind of folded those 3 main lines. And then for each glue tab, let's go ahead and fold those in just a little bit. Get those ready. Okay. Notice above where it shows that found in Earth's oceans and the little whale, there's a black line. That's actually where we're going to end up taping one of our pieces of string. All right, so now that we've got all those together, you can kind of just play with it a little bit so you can see how it's going to go together, okay? And it gives you an idea of what you're aiming for. So now that I've done that, you might notice it might help a little if we bend in the triangles that are on either side of our boxes. Okay. All right, so at this point, we need to go ahead and just add some glue to every tab that says glue tab, okay? Just try not to add too much or you'll end up with a mess. All right, I think I got all the tabs. So altogether there's 7 tabs, 3 along the bottom long side, 3 along the top long side, and then 1 on one of the short sides. All right, so let's just kind of start bringing it in. And this is just going to take a little bit of finessing probably. Don't get too frustrated. So once we have the 3 main sides with the boxes together, then we can kind of play with these other ones at the top and the bottom a little bit. Okay, and then you're gonna need to hold it once you pretty much have it where you want it together for at least a few seconds to let that glue dry just enough to keep everything together. You know what? I think I missed glue right here. There we go. Now, worst case scenario, you do have some tape. You can always use tape if you really start struggling, or if there's one area where for whatever reason the glue doesn't take well enough. See, like right here, I would probably grab some tape and just tape this part right here because it seems to be one of those areas. And the tape's pretty good about just tearing, but you can always use scissors too. right, last thing we need to do to make sure this is all complete, you should have your set of shells and your atom all together. You should have your 3D element box. You're going to need to have the string and then your tape, okay? So let's start with the element box. Remember I mentioned earlier this black line. You're going to want to cut about 2 to 3 inches, however long basically you want the element box to be hanging down from the atom, okay? So just cut a little bit of string off like this. You're going to take one little piece of tape, and where that black line is, you're just going to tape the string on there. Okay, and because these are so light, it doesn't have to be like this monster type tape. That should hold just fine. Okay, then grab your atom and you're going to just tape it to the bottom of that third shell. So if you've realized that, oh, I don't want it to be quite that much farther away, you can always trim that down, okay? You can always put another piece of tape on the other side if you want as well, okay? So you've already got this all together. Now all you need to do, one last thing, is take the rest of your string, okay, and you're going to tape it to the top of the atom. Just like that, okay? And now you're going to be able to hang it wherever you would like. If you made it this far, I wish I could give you a pat on the back or a fist bump or a high five or something, because this is not for the weak of heart. So if you made it and you've got your atom, you should be really proud of yourself. All right, I hope I will see you next time on the last set for middle school chemistry.